The multi-resolution modifier allows us to control how much geometry our models have depending on the specific task that we are currently trying to complete, whether this be traditional 3D modeling, sculpting, or rendering. To access the multi-resolution modifier, go to the Modifiers tab in the Properties panel. Left-click and then select Add Modifier. From here, choose the Generate option and then choose Multi-Resolution. This will add the multi-resolution modifier to your object. The multi-resolution modifier has a few quirks that you should know about. In this example, I've created Suzanne and I've used the Subdivision Surface Modifier to increase the geometry on Suzanne. Watch what happens when I attempt to add a multi-resolution modifier. When I do so, you'll see that multi-resolution has been added on top of the subdivision surface. But what if I chose a different modifier, such as the bevel? This seems to add it below subdivision surface. So let's return to multi-resolution and let's try and position subdivision surface above multi-resolution. So I'm going to go left click, drag it up above and release. It actually isn't able to do so. The reason why is the multi-resolution modifier is perhaps the one modifier that requires the original data of the mesh. It cannot work after another modifier has made a change to the mesh object, unless that modifier has of course been applied. I'm going to remove these two modifiers, and just to hammer home the point, I'm going to add multi-resolution and then the bevel modifier. This adds it below multi-resolution, but if I click and drag to move it above, we get the same issue, and you can see the error message at the bottom of the Blender UI. Multi-resolution requires the original data of the model. It cannot work on a mesh that has been edited using another modifier at that point. What this means is that we make any changes we can here with multi-resolution, and then we can use other modifiers like the bevel modifier to add to the detail created using the multi-resolution modifier, but we cannot do the reverse. For now, I'm going to remove the bevel modifier and let's take a look at how we can use multi-resolution itself. Now, the very first option that I want to turn your attention to is the ability to subdivide your mesh. This is important because the top three options, which define the levels visible in the viewport, in sculpt mode and in render, are set to 0 and they cannot be changed until we add levels of subdivision to the multi-resolution modifier. So watch what happens when I click on the Subdivide button. Left click and all of the levels go up by 1. I'll click again to add an additional level. Click a third time and we now have 3 levels of subdivision. From here we can now adjust these 3 values between the range of 0 and 3. So I can, for example, reduce the number of levels in the viewport to 0. I can reduce the sculpt level to 2 and keep the render level at 3. Or I could reduce the render level, increase the sculpt and viewport levels. I can do whatever I want with each of these values within the defined range, and that defined range is based on the number of times we subdivided the mesh. So again, I can add one more subdivision if I feel like I need that little bit more detail, and it will bring all of the values up to 4, but I'll be able to change each of these values within the 0 to 4 range. To get a clearer idea as to what this is doing, I'm going to turn my viewport levels to 0, sculpt levels to 2, render levels to 4. So at the moment we can see in the 3D viewport our object with no levels of subdivision added to it. If we go from object mode to sculpt mode, you can see that we straight away have our subdivided mesh to a level of 2. If I was to move back into object mode, just preview the object within our camera view, and now let's render our image. This is going to render Suzanne, but with 4 subdivisions. So in 3 different areas of our project, we have 3 different levels of subdivision active at the same time, depending on which one we are using. There are a few reasons why you would want to use something like the multi-resolution modifier. The first and most important reason is performance. You may want to render at a very high level, but you may not want to work with that dense geometry in the 3D viewports, so you can control the viewport levels, and this will improve the general performance of Blender while you're working on your model. It could also be the case that you want to save on performance in Sculpt mode. By defining the resolution value in Sculpt mode separate from the viewport, you can maintain more detail than what you would have to work with in edit mode, but not so much detail that when you are trying to sculpt the model, you end up with performance issues. So in this example, I have viewport levels set to 1, which is perfect for performance in edit mode. I have sculpt level set to 3, which is 1 below the render, so I've got a lot of geometry to work with, but at the same time, it's not so dense that I may end up lagging in the viewport, and then the render can always be my max value because that's where I'm going to want the most detail. Another reason why you may want to use the multi-resolution modifier, in particular with sculpting, is when you create a low poly mesh as a base and you want to create a high poly version on top of it, the multi-resolution modifier is invaluable at allowing you to create that higher detailed model. And then the third reason why you would perhaps want to use the multi-resolution modifier is in animation. So let's say you were animating a model and you were doing up all of the keyframes, the lighting and everything, and you were previewing the model in the 3D viewport. Well, previewing your animation is very performance intensive, and so you'll want to use the lowest number of viewport subdivisions that you can possibly get away with while previewing your geometry as you complete each stage of the animation process. Sculpting is perhaps the number one reason why you would want to use multi-resolution instead of Subdivision Surface. So what I'm going to do here is I'm just going to take this model and I'm going to just duplicate it to create a second object very similar, and with this duplicate I'm going to replace multi-resolution with Subdivision Surface and set the levels to 3, which should be equivalent to what we get here with multi-resolution when working in Sculpt mode. Now, selecting the second object, I'm going to return to Sculpt mode, and let's just try and manipulate some of the geometry. So I'm clicking and dragging, but not a lot seems to be happening here with our model. And the reason why it's so unresponsive is because with Subdivision Surface, the sculpting toolset is working on the base mesh and not the subdivided geometry. Let's compare this using the same tool with the original object in Sculpt mode. So here, I can click and drag and you can immediately see how much easier it is to apply new detail to the model when using multi-resolution rather than Subdivision Surface. This is because the Subdivision Surface modifier only works on the base mesh, and that means that the sculpting toolset is only going to function on that base mesh and not the added geometry until it's applied, of course. But with multi-resolution, we can actually work on our models in Sculpt mode, and we can change the level of subdivisions however we want while working in this mode. So we're changing the amount of detail here in Sculpt mode using this parameter. And no matter what parameter we use, we're able to add new geometry using that value. So here I can just add whatever I like. And I'm just clicking and dragging, but you can see how much easier it is on one model compared to the other. Below these three options, we have a tick box that allows us to sculpt the base mesh. Now, the big advantage with multi-resolution over subdivision surface was the fact that you would be able to manipulate the finer details of the geometry created from your subdivision by using multi-resolution. However, if you want the multi-resolution modifier to mimic the subdivision surface modifier by sculpting the base geometry rather than the newly formed geometry, you would tick this option here. Now, if I was to zoom in on this model and click and drag, you would see that there's a lot less of a reaction from our model, and that's because as I click and drag, the only geometry, the only vertices that are being affected are in fact the vertices that were originally a part of the model before we added the subdivisions using the sculpt value. So you would have this ticked if you wanted to use specific tools that would allow you to manipulate the positioning of the original vertices or the base mesh, and you would untick this option if you wanted to manipulate with your various brushes the geometry that had been created as a result of the sculpt value in the multi-resolution modifier. Then we have optimal display, which is ticked by default. Now this will skip the rendering or drawing of the interior subdivided edges, but the best way to demonstrate this is actually using the layout workspace in object mode while having the wireframe viewport shading enabled. So currently we're in sculpt mode, and if I was to enable wireframe, which is this option here, you can see all of the geometry that has been generated in sculpt mode using this value. If I turn this off, it's not going to change anything while we're in sculpt mode. This is more for the render and level viewport values here. So if I go from sculpt mode to object mode, you'll actually see that the geometry has significantly decreased while using wireframe viewport shading. If I turn this off though, we can actually see even more of the geometry. So all of the geometry is displayed in wireframe mode when we have optimal display unticked. And keep in mind that we are using level 1 for the subdivision of the viewport. If we increase this value, we can increase the number of subdivisions and the amount of detail on our model while viewing through object mode. And when we tick optimal display, while working with the wireframe method of viewport shading, much of that geometry is made invisible. This will help further improve performance while manipulating our objects in object mode in particular. For now, I'm going to reset this to 1, and let's just return for the moment to sculpt mode. There are 3 methods of subdivision when using the multi-resolution modifier. These are Subdivide, Simple, and Linear. Here I have 3 cubes, and each cube is going to be used to represent each method of subdivision. The first method is Subdivide. This is going to subdivide our geometry into multiple smaller faces, while at the same time smoothing the geometry to a more spherical form. This is equivalent to using the Subdivision Surface Modifier and keeping it on the Catmull-Clark method. Each time we click on the Subdivide button, we will not only increase the amount of geometry on our selected object, but we will also continue to round out the object using a method of smoothing for our geometry. We then have the simple option. This is the same as the subdivide option, but the key difference is when I left click, we increase the number of subdivisions, but it does not change the shape of the geometry. The simple method for subdivision will simply increase the amount of geometry on the model, but will not apply any smoothing to the base mesh. This is most similar to using the Subdivision Surface Modifier with the simple method active. So you can see here that, like with multi-resolution, Subdivision Surface is not rounding out or smoothing the geometry with the simple method, whereas with Catmull-Clark, it's going to begin to smooth around the geometry that already exists. The third method is the linear method. Now initially, when we left click on the linear option, it's going to have a very similar effect to the simple method for subdivision. The key difference is that the simple method will use a simple method of interpolation to create the geometry. However, the linear method will use a form of linear interpolation and will take into account changes made through sculpted displacement. In other words, what you do in the sculpt mode for Blender is going to have a small effect on how future subdivisions are created using the linear option. Now for the next level, I'm going to use the Suzanne which had the Subdivision Surface Modifier added to it. If we take a look at the versed Suzanne, we have the option for the Unsubdivide tool. Now what this will do is it's going to rebuild a lower subdivision level, but it's important to note this will do so with the current base mesh. It ignores everything else within the multi-resolution modifier. This is a mistake a lot of people have. They tend to think that Unsubdivide is used to revert the subdivisions made by multi-resolution, but there's no point to that because you can already manipulate the values in the viewport, sculpt, and renders. What this actually does is it will take information for your object, and if it can unsubdivide the base mesh, it's going to do that, and then all of the other parameters are going to be added to the model. So let's take Suzanne here. We can see with Suzanne that we have 3 levels of subdivision. Now if I was to click unsubdivide with the original Suzanne, left click, you'll see no valid subdivisions found to rebuild a lower level, because it's actually using the original default form of Suzanne, which itself could not be unsubdivided, at least not without destroying the model. However, with this Suzanne, we're going to apply this modifier. So now our second Suzanne has a lot of geometry to work with, and a lot of this geometry was created using subdivision. That means that there are now lower levels that we can access if we go to the multi-resolution modifier, and we don't even have to change anything with these values. This is entirely unrelated. Watch what happens when I click the unsubdivide button for this Suzanne. Left click, and you'll see after about half a second that the geometry starts to decrease. If I left click again, we reduce the geometry further. So we're unsubdividing our geometry each time we click unsubdivide until there are no further levels for the object to be unsubdivided. If you take a look at the multi-resolution modifier now, you'll actually see that our render setting has been set to 3 levels of subdivision here. So when we used the unsubdivide tool, it calculated how many subdivisions there were initially and added that to the render value. Then we simply used unsubdivide to continuously lower the base mesh geometry. Below that, we have the delete higher option. Now what I'll do here is I'll just increase the viewport and sculpt levels both to 3 with the multi-resolution modifier. And if I click on the delete higher option, nothing's going to happen initially because all 3 of these are the same level. but let's increase the render value by just subdividing a bit more and bringing the viewport and sculpt levels back down, and then select delete higher. This is going to lower the highest value, which is typically the render, and it's going to reduce that level to the same as the viewport level in this case. If we were to increase the render back up to 5, bring the sculpt down to 3, and bring the viewport levels to 1, and then choose the delete higher option, it's going to take both the sculpt and render values and lower them to the viewport value. A little hint: while working in sculpt mode, you can increase and decrease the number of subdivisions used in sculpt mode by holding down the Alt key and pressing 1 to reduce the number of subdivision levels, and 2 to increase the number of subdivision levels, in between the minimum value, which is 0, and the maximum value, which will typically be what your render is, or however many times you used one of these subdivide options. Here I'm just going to once again demonstrate the visual difference between a simple subdivision and a linear one. So I'm going to add multi-resolution to this object, and I'm going to start by adding some initial detail with the simple subdivision method. This is just so that we can increase the amount of geometry that we have to use. Then we're going to go into sculpt mode, and we're just going to sculpt a little bit of detail on this object. So let's use, from here, I'm just going to use the grab brush. We're just going to grab and just move things around a little bit. And I'm not doing anything in particular. I'm just looking to just create something that looks a little bit less like a cube with the geometry that we've sculpted. Okay, so for this demonstration, I'm going to pop back into object mode so that we can best see our model. And now, looking at the object from the side, I want to use either simple or linear subdivision. Now watch what happens when I use the simple method for subdivision to the geometry that has been altered. When I do that, it creates the additional geometry, but there is a bit of smoothing going on where the geometry was sculpted. So the simple method uses a very simplistic form of interpolation to locate where the geometry is and then subdivide it. But because it's just a simple method of interpolation, it can also begin to smooth out the geometry as well while calculating. By contrast, we would have the linear option. Now if I was to use Ctrl Z, we'd be able to bring this back to the previous state. And now let's go with the linear option. And when I choose linear, you'll notice that additional geometry was generated, but the general shape, the structure, and the pointiness of the detail, they've all been maintained. So with the linear subdivision method, this is the one that you would actually want to go for if you want to keep the sharp edges on your sculpts, rather than the simple method, which is better used for the flat surfaces where you just want to increase the amount of geometry. Below the subdivision section, we actually have a few more areas of the multi-resolution modifier. Let's take a look at the shape section, where we have two options: reshape and apply base. First of all, when it comes to reshape, we require two objects for this to work: an initial object and the model in which we want to map the vertex data to. So we're taking the vertex data from the initial selection, and we're going to use that to transform the current model. Here, I'm ensuring that my second Suzanne is selected. I'm going to open up the shape section and watch what happens to certain areas of the geometry when we select reshape. You'll notice that it's a little bit more puffy here. Some of the vertices and faces around here have been remodeled to an extent, and this is because we are mapping the vertex coordinate data from our first Suzanne over to the second. Now that's quite a subtle change, so I'm going to use Ctrl Z to undo the shape tool. We're going to go back to our original model, and we're just going to do a little bit of additional sculpting here. So let's say I just wanted to inflate the top of Suzanne's head. We'll bring it out to about there. And then we'll return to object mode, ensure that this model is selected first, then the correct Suzanne model selected second, go shape, then reshape, and you can see just a little bit more how the vertex data has been shifted on the selected object. And if we go into sculpt mode, you can also see how the geometry has been deformed in a manner similar to that of the original model. Again, it's important to note that this will only work if you have objects that have comparable levels of geometry. If we select this model and then move into edit mode, you can see there isn't that much that has changed when it comes to the actual geometry of the model. It's only when viewing our object in either objects mode or in sculpt mode that we really see the changes that we've made to the object. However, we can apply the base mesh. So we can apply these changes to the base model, and this is going to change where those vertices are located in edit mode. Again, if I select the original model and go into edit mode, you'll see that it just looks like Suzanne normally would. The same with our newer model here. But if I was to select apply base and then go into edit mode, instantly you'll see many of the vertices have been repositioned, and it looks a little bit more like a low poly version of our sculpted mesh. In the generate section, you'll likely see only one option: to save an external file for the displacement created by your sculpt. However, before we move on to that, I want you to know there is a second option, but this second option only appears if no subdivisions have been made with a multi-resolution modifier. So to demonstrate this, I'm just going to hide my current objects, and let's just add in a new monkey mesh. And from here, I'm going to use Subdivision Surface up to a value of 2, and then select Apply. Then I'm going to add the multi-resolution modifier, come down to where it says Generate, and you can see here that we have the ability to rebuild subdivisions. So I just applied Subdivision Surface, and that means when I go into edit mode, all of this geometry is accessible but also permanent unless I use Ctrl Z. But watch what happens when I click on the rebuild subdivisions, particularly to our 3 values at the top. I'm going to left click, and all of these values have now been increased to 2. If I reduce the level viewport subdivision value, you can see that we are able to reduce the number of subdivisions on the model. You'll also notice that the Apply Subdivisions option has disappeared from the Generate section. Again, this only exists when the multi-resolution modifier has not used any subdivisions itself in any way. As for the Save External option, this allows us to save the displacement generated using the multi-resolution modifier and the editing tools in sculpt mode, and it allows us to save this displaced geometry as an external file so that we can use for other models. This is classed as a .btx file, and it's kind of similar to a texture map, but instead of using an image texture, the information it stores is related to the vertex positions and their levels of displacement from the original positioning of the mesh. So here, for example, we can name this anything we want, so just test.btx, but we make sure that the file name is correct, and then we click on the option that says MultiRes Save External. It then creates a file path that allows us to access this .btx file. It's now technically an external file that our project is currently using. If we were to click on the pack option, so pack external, it effectively does the complete opposite. So when we save a new .btx file, we go to the file browser, we define its name, we click on the MultiRes Save External option, and then we'd be able to use that file path or other file paths by opening up this browser or this directory and then picking the file path that we want to use for the displacement. If we wanted to pack that specific .btx file, whether or not it was created in the same project, all we would need to do is click on this option, and then we would be using that data locally within our project. The final section in the multi-resolution modifier is the advanced section. Now, what's important about this area is that all of these parameters need to be adjusted before you begin to use the subdivision parameters of this modifier. So before you make any changes anywhere else, you need to define all of these parameters if required. The reason why is if I click on the Subdivide option, for example, all of the advanced options will grey out. So from the moment that you add levels of subdivision to the multi-resolution modifier, you will no longer be able to use the parameters underneath the advanced section, because the purpose of these parameters is to determine how the subdivisions are going to operate on your model. For now, I'm going to use Ctrl and Z to undo that so that we can go back into advanced and take a look at a few of these settings. The first option is for the quality of the generated vertices. The higher the value, the more precise the vertices that are created will be. So they'll be positioned correctly in the more complex areas of the model. If you lower the quality value, then some of your vertices may not be lined up in the same location, and while the performance of the multi-resolution modifier can improve by lowering the quality value, the overall topology may not be as efficient. As with many of these advanced options, it's recommended for now to keep things at the default values, and only change them if really necessary and if you really know what you're doing with them. The UV Smooth option relates to how the new geometry is going to be applied to the UV map of a given object. As a reminder, a UV map is the representation of your object's geometry on a 2D plane, which can be used to apply textures to your 3D objects. Now, in our UV editing workspace, we'll only be able to see the original geometry. However, the UV smoothing option allows us to edit how the new geometry is going to be added through the multi-resolution modifier when textures are created or multi-resolution is applied. If we open up this UV smoothing menu, you can see we've got multiple options, but the best way to describe these options is that each option within this menu increases the amount of the geometry or the number of UVs that are going to be smoothed as a result of the multi-resolution modifier. Think of it in a manner similar to when you use the Subdivide option, and I'll just use it temporarily, and this will not only increase the amount of geometry, but it will also smooth out the vertex positions. The UV Smooth option will smooth out those same vertex positions within your UV map. However, the option that you choose from this menu will determine how many UVs and where will the smoothing be applied. So if you set it to none, then no smoothing of the UVs is going to be added in the UV map, which you can find here. But if you want to smooth all of your UVs, including the boundaries, which are the areas that surround each island, so basically these vertices here, they're part of the boundaries for each island of the UV map, then you would set this to all. If you wanted to smooth everything but the boundaries, you would choose the keep boundaries option. And this tends to be the default and the one that you would normally go with if you've already added a texture map to your model and you don't want the texture to start warping over those boundaries. The Use Creases checkbox allows us to determine where on our model we can maintain a level of sharpness when using subdivisions. In this example, I'm going to take this Suzanne object. I've selected the outer vertices of the face, and I'm going to open up my side panel, come down to where it says Edges Data in the Item tab, and increase the mean crease value. So this is the weighting that is going to be used by the Subdivision Surface Modifier as well as the Multi-Resolution Modifier. So we're going to click and drag to push this all the way up to 1, come back into object mode and then increase the level of subdivisions, and pay attention to the sharpness of the edges around the face. So I'm going to use subdivision multiple times, and if I zoom in, you should be able to see just how much sharper the area around the face has become. Now if I was to press Ctrl Z a few times and turn off the Use Creases option, watch what happens when we subdivide our geometry again. Keep in mind, we've still marked the crease value for that selected geometry. So we're going to use the subdivided tool, and you can see it's now smoothing much more naturally because we've turned off Use Creases. The same effect can also be made visible if we were to take that geometry and reduce the mean crease value to 0. At that point, it wouldn't matter if this box was ticked or not, because all of the vertices on our model have a mean crease value of 0. And as a result of that, when we increase the level of subdivisions, everything gets smoothed naturally. The Use Custom Normals option allows us to maintain changes to the normal behavior of our individual faces when we subdivide the mesh using this value. For the moment, I'm going to remove multi-resolution, and the best way to demonstrate this is to actually edit the normal direction of many of our faces. I'm going to enable face orientation. This allows us to preview the direction in which the faces are pointing. If it's blue, that means it's effectively facing outwards, which is correct. And if it's red, that means that it's facing inwards, or we're looking at the inward face, and that is incorrect. I'm going to add a modifier, but this is going to be a weighted normal modifier. And this is going to allow us to change the shading that we can see on our model by adjusting the normal direction of each face. I'm going to reduce the weight value to a very low value so we can see a marked difference. And I want you to pay close attention in particular to just under the eye for Suzanne, so we can see the shade is a lot darker here. And just keep an eye on where the shade is lighter and where it's darker, because if we manipulate this weighting, that positioning of the shaded areas changes quite significantly. So I'm going to set this to a very low value, and then I'm going to apply. Next, we're going to add a modifier, which is going to be our multi-resolution modifier. Open up Advanced, and for the moment, I'm not going to use custom normals. So watch what happens to this area in particular under the eye as I subdivide. Immediately, the shading is going to shift. So the shading is going to recorrect itself based on the default normals of those faces. However, watch what happens if I was to turn on use custom normals and then use the subdivide option. We're increasing the geometry, but the shading hasn't shifted. The darker areas have remained dark on our 3D objects, and this is because we have maintained the changes made using our weighted normals modifier on our 3D object while adding subdivisions. Finally, we have the boundary smooth option. Now this is typically used for objects like cloth materials, for example, where we are working with very simple plane shapes and then adding geometry later on to create things like cloth simulations. The idea here is that when boundary smoothing is set to all, then all of the geometry is going to be smoothed as a result of the subdivide option. So if I left click, you can see that our plane object becomes effectively a circle. However, if we open up the boundary smooth option, we can choose to keep the corners. This locates the boundaries of our model and attempts to keep them as sharp as possible. So with this option selected, if I go subdivide and do so multiple times, it will maintain the sharp corners of our plane whilst also subdividing the mesh. So that about wraps things up with the multi-resolution modifier. If you found this video helpful, don't forget to like, subscribe and hit that notifications bell icon for future updates and videos relating to Blender and its many tools for 3D modeling. For now, I'll see you later.